Hello everyone, welcome to the channel. In this video we'll fine-tune BERT model on token classification for named entity recognition on legal documents. The same notebook can also be used for parts of speech tagging. But first we need to prepare fine-tuning dataset. I'll use this dataset for fine-tuning. It has text with start and end position in the string, with corresponding class label. Now, to train on token classification, your dataset should look like this. Each token has a corresponding label. Let's filter out rows without entities. Instead of having single label class, I'll use two classes for same label. One for the beginning and another for inside. This can be helpful in differentiating adjacent text segment having same class label. We should carefully create tokens and assign class label, as a single word may result in multiple tokens. Unlabeled text will be tokenized and stored with label 0. Then we store named entity tokens, with beginning and inside class labels. I'll assign label with B to first token of named entity, and I for the rest. Rest of the text will have class label 0. Each token have correct class label. Let's create new dataset with desired features. Let's keep only rows with token count less than 500. We now have our dataset in proper format. Let's load the dataset. We need to change model configure bit, first assign ID to label, and add number of labels to config, as the classification model expects it. We have our BERT model, with a linear layer on top, to predict class label. To create batched input, I'm first converting tokens to string and give it to tokenizer, with padding set to true. We ask for attention mask, to ignore attention on padding tokens. We don't want special token added to strings. Our labels are all aligned. We just need to add ignore index for padding tokens, up to max length. Let's check if our Collator function is working fine. Class labels are correct. If you allow special tokens, then our labels will be misaligned. Let's start fine-tuning. After 3 epochs, model starts to overfit. Let's check predictions by our model. The predictions are accurate. So this is how you can fine-tune BERT model for token classification. If you liked this video, don't forget to subscribe to my channel. Thanks for watching, see you in next one.